Thank you very much, Will. I'm so happy to be here to talk to you today and to be talking to Professor Shashua about OrCam and the various products they have. And I certainly think that there's an enormous opportunity here, as obviously Professor Shashua does, in this industry to leverage AI and leverage computer vision to help enable better processes and better accessibility for people with disabilities, people with vision loss, and people with hearing loss. So I'm excited to talk about this today. And thank you very much for being here, Professor Shashua.
Thank you, Matthew. It's a pleasure.
So I think that there's a lot of ways to start off this conversation, but I think a basic one is why you see AI as an enormous opportunity to leverage here, to get significant advances for people with disabilities that could benefit from it.
So when you look at the AI, it's playing out in two major domains. The first domain is machine vision, the ability to see and interpret the visual data that's coming into the machine. The last 5 years have been, huge leaps in the ability of machines to interpret visual data and to reach performance levels that are rivaling human level perception. The second one is understanding acoustics, understanding sound, voice to text, and understanding text. This is called natural language processing or natural language understanding. This area has also received huge leaps in the past 5 years. So now if you put both of them together and add to the mix also the rise of compute, the fact that silicon is becoming more and more dense in compute and the power consumption is getting lower and lower, the ability to put things that could be very compute intensive, but when are running on a battery. If you look at our smartphone today is like a supercomputer of 10 years ago, and it sits in our pocket. So if you put all these things together, it's like stars aligning in a perfect line, that you start seeing a huge value, especially for people who have disabilities. So if you have difficulty to see, the machine can see for you and then whisper into your ear what you're about to see. And then you can also communicate with the machine by talking to the machine, like we talk with Cortana, Alexa, and then Siri. Right. So if the machine is looking at the visual field and you want to know what's out there, rather than the machine telling you everything it sees and giving too much information, you can start asking a question. What's in front of me? Guide me to that place. If I'm looking at a newspaper, read me titles, and then read me article number 3, or read me an article about Biden, or you can start exploring the visual world, because there's also a natural language processing interface. So if you put those things together and put it on a wearable device, then it's like you are emulating a human assistant. It's like I have someone smart enough with proper hearing ability and proper seeing ability standing beside me, and I'm communicating with this person. And this person is telling me about the world. It's telling me about what I'm seeing, whom I'm seeing. I can ask this person, tell me when I see Matthew. So I'm going from place to place, and you'll tell, here's Matthew, because I don't see, right? Or I can, tell him, guide me to the next empty seat. I'm going on a bus, and I'll tell him, guide me to the next empty seat. So this human assistant will tell me, here's an empty seat. So now replace this human assistant with a computer, and you can start appreciating the big value that you can get. And it all sits on a very, very small device, because of this rise of compute, rise of data, rise of machine learning, of deep networks, natural language processing, natural language understanding, computer vision, all coming into a climax in the last 5 years. Makes it a huge opportunity for helping people.
Yeah, and there's a lot of components there. Obviously, you do have the advances in natural language processing, but also semantic understanding of the world. As you mentioned, it's one thing to say, hey, there's text in the field, I'm going to automatically read that, which I believe we've seen some applications of that, across voiceover and across other technologies. But certainly there is an advancement here in the way that it segments the world semantically to understand if, for instance, a paper is being held up closer to my face. I want to read that. I don't want to read a sign in the distance, right? And that's one of the advancements that I believe has been added to the OrCam camera recently, right?
So when we started with the OrCam camera, the OrCam was founded in 2010.
Mm-hmm.
So we're talking about at least 4 years before the rise of deep networks. But we felt that computer vision was at a point in which we can do something useful. We did something useful in terms of Mobileye with the perception driving assist, where the camera can do very, very useful things in avoiding accidents by detecting people, detecting cars. We thought we can do the same thing, and let's focus on recognizing products, recognizing money notes, recognizing faces. Faces came out a bit later, but mostly recognizing text. An ability to do OCR, optical character recognition, in real time in the year 2010 was what was groundbreaking, right? But then as we moved forward, the first thing we told ourselves, well, how would the user communicate with the device? So in 2010, the way we communicate with the device were the hand gestures. So if I want to kind of trigger the device to give me information, I'll point, and the device sees my fingerprint. Or if I want the device to stop whatever it's doing, I'll do something like this. So hand gestures. And then later, as we moved forward and technology progressed and compute, silicon became more and more dense, and algorithms became much more powerful than they are today. Data became much more available. We said, okay, we can use natural language processing, natural language understanding in order to guide, in order to get a good interface between the human and the machine. So now, if I'm looking at the newspaper in 2010, it will read the entire newspaper. But now I can say, read me the headlines. And then I'll say, read me article number 3. Or I can tell the device, detect number 23. So while I'm moving, so I'd say I want room number 23. When I'm walking along a corridor, and I want room number 23. So stop me when you see the number 23. So I'm communicating with the device like I would communicate with a human assistant. Or say when I'm looking at a menu. In 2010, it will read the entire menu. Now I can tell, okay, find desserts. So it will read me only the desserts. Or start from fish. It will read me something that's starting from fish. Mm-hmm. So the addition of first, computer vision became much more powerful. So we can do much more than we did just back in 2010. But also the combination with natural language processing made it very, very powerful.
Yes, and I think there's a huge key here, which is you sort of touched on a little bit here and there, but I think is important to talk about head on, which is that all of this is being done via on-device processing with OrCam. And I believe that that's huge for a lot of reasons. One, it's technologically impressive. But second, it is sometimes underappreciated how intimate accessibility devices can become to the user. They're letting them into their lives. They're asking them very personal questions. They're opening up their world in a visual and auditory sense with acoustic filtering and acoustic recognition. And all of those obviously raise privacy questions. If we're basically saying this is an extension of my being, privacy and intimacy and closeness of that data becomes massively important. And I think a lot of the other accessible devices or accessibility devices on the market, much of them rely on cloud connectivity. And there will be single features here or there that are local on device. So can you talk a little bit about that road to ensuring that you could do all of this on device on a battery powered unit? Because I think that's one of the most singularly impressive things about OrCam.
I think that early on we understood that this is the most critical challenge that we need to face. First, if we want a device that sees everything that you see, and hears everything that you hear and processes it. If you send all the data to the cloud, you'll be entering into huge privacy issues. We did have 2 years ago kind of a test in the water of such a device that was focused only on face recognition, and we went through a Kickstarter we kind of shipped 1,000 devices that are focusing only on face detection, where the information is being sent to the cloud, because there in the cloud, you have all your database of faces and so forth. And it hit huge privacy concerns. So we stopped with those 1,000 devices that we shipped. Processing private information in the cloud is very, very problematic, especially when we're talking about visual information and auditory information. So it has to be, the intelligence has to be at the edge, has to be wearable. And this raises lots and lots of challenges. One is power consumption. Second is processing power. Right? In the cloud, you have unlimited processing power, and here you have to have a very, very small amount of processing power because of power consumption, because of size. There's also practical considerations. So even if I wanted to send something to the cloud, sending high-resolution images to the cloud would not make the device work in real time as it should, right? Because the fact that everything is done on the device allows us really real-time processing and provides much more value to the user. So being able to cram everything into a device of this size, and this is kind of the device for the visually impaired, cram everything in a device of this size and have it work for a number of hours in full capacity by processing audio and vision is a huge challenge that OrCam had to face early on, and it pays back. It pays back because people feel that there are no privacy issues. They can trust the device because nothing is being sent to the cloud. There's no communication to the cloud, no communication whatsoever.
Yeah, and I think that trust is important. Obviously, when you're saying, hey, we're producing a device for you that does enter into your personal universe. But that technologically speaking, I think that the computer vision is somewhat understood by a larger percentage of the populace than it was, say, in 2010. People are starting to see applications of this in their daily lives, from the iPhone's camera to Google's Photos application, which automatically selects faces and themes for people and things like that, and visual search, obviously, in photo libraries. So they're starting to see some applications of that in their regular life. And of course, the Microsoft Connect had a lot to do with that, kind of exposing that to a mass audience. But I think it's much less so far with auditory signals. And so could you talk a little bit about the OrCam here and about the applications there and the development of that?
So when you look at the processing acoustics, we took it into two directions. One is for the OrCam Eye, for the visually impaired, being able to communicate with the device. As I mentioned before, you can talk to the device. The second area was creating a new product line that will help people who have hearing loss, even mild hearing loss. And the idea is that there is an open problem. It's called the cocktail party problem. Has been open for about 5 decades in the academic circles, which says when you are in a situation in which many people are talking at the same time, and you are having a discussion with one specific individual, you kind of tune into what that person is saying, and you tune out everything else. And it's kind of miraculous. How do you do that? You follow the lip movement. You do something quite miraculous. And the past 2 years, the kind of the rise of deep networks, the ability to build architectures that can process together acoustics and video. One could do things that 10 years ago would be considered science fiction, and solving the cocktail party problem is one of them. So the idea is that you have a black box, which is a network. It receives the acoustics and receives the video of the person that you are looking at. Now, the acoustics would be the voice of the person that you are talking with, but also the other people talking, right? You're on a cocktail party, you're in a restaurant, you're having a discussion with the person in front of you. There's background noise of dishes clacking and all sorts of background noise. Table beside you, there are other people talking as well. And all what you want to hear only the person that is in front of you. Tune out everything else. So this network receives all this complicated acoustics, receives the video of the person that you are looking at, somehow follows the lip movements, and then extracts from the acoustic wave only the voice of the person that you are talking with, and transfers that to your hearing aid. So it could be a hearing aid, or it could be just an earphone. It could be that you have a mild hearing loss. You don't need hearing aids, but you would like, at this particular setting of a complicated acoustic setting of a restaurant, put in an Apple AirPod in your ear and amplify only the voice of the person in front of you and tune out everything else. And this is something that is not possible to do from a technological point of view. And we kind of capitalized on several things that OrCam was very good at. One is taking very, very advanced technology and putting it on a very, very small device, kind of advanced technology in terms of computer vision, in terms of natural language processing, in terms of deep nets running on a very, very small device, and taking our vast experience in computer vision and natural language processing and natural language understanding that we did for the visually impaired, and building those architectures that can solve the cocktail party problem. And this is kind of the device OrCam here. The idea is that, you simply put it on your neck, and then the camera is facing the person that you are talking with. In this case, it's just a normal earphone. I put the normal earphone, and then I can, tune in into the discussion of the person in front of me. And what this device does is the camera here and has a number of microphones. The camera and the microphones together, take the complex acoustics and the video of the person in front of you, feeds it into kind of a miraculous, black box neural network, and out of this neural network comes a new acoustic wave, which tunes out everything else except the voice of the person you're talking with.
Mm-hmm. And how do you go about training a network like that?
This was one of the big challenges, as it's one of our trade secrets even. How do you go and train such a network? So what I would say is that one of the big advancements in the past 2-3 years is called self-supervision. Self-supervision, unlike the classical machine learning where data needs to be tagged. So say I want to recognize cars in an image. Then I'll go through a process of collecting training data and then tag every vehicle in that collection of images and feed this into a neural network, telling them, here's an image as an input, and this is a car, right? I'm tagging it. And this requires a lot of effort and limits scalability. The past 2-3 years in machine learning has shown a lot of progress in self-supervision, where you don't need to tag anything, you don't need to label, label anything. It started with language processing and then shifted to computer vision, unsupervised learning or self-supervision, and we harnessed this new advancement so that we can then take the entire internet of clips, wherever clips are, and use it for training this neural network. So without tagging, without labeling anything. So being able to train such a network is really a big part of the technological ability of the company. It's not only putting everything on a small device, it's being able to train it. With.
Right. And to talk about hardware for a second, though, I mean, I think it would be interesting to hear your view. I mean, obviously with your first company or your previous company, and then now OrCam, you're dealing with on-device processing that uses specialized chips. And I'm just kind of curious about how you view the entire industry of specialized chips, specifically as it relates to AI. We've seen obviously the biggest AI and ML applications, obviously, but we've seen the biggest example of this being, Apple launching a dedicated coprocessor for processing ML more rapidly and more efficiently. But of course, NVIDIA is a big player in this space. Intel is a big player in this space now. And I'm just kind of curious what your thoughts are on the industry at large. I mean, the advancement of specialized chips seems to be driving a lot of the innovation around these devices, specific devices. OrCam's one example, that take on tasks that require a lot of very specific actions versus the generalized processor universe of 10 years ago.
Well, it's a spectrum, and you need to place yourself optimally in this spectrum. So on one end of the spectrum, you have general purpose processor like a CPU, and ease of programming, very, very easy to program. So this would be the CPU, this would be the NVIDIA GPU with the CUDA processing language. It's very, very natural to write code for this processing. On the other side of the spectrum, you have very, very hard to program, very specialized architectures, very efficient in a very, very narrow domain. So it will be, say, very efficient in running a specific type of a neural network. It will be much, much more efficient than a general purpose processor. The problem with it is very, very difficult to program. So it's difficult to scale. And also because it's not general purpose, say technology is evolving and technology is evolving rapidly. It's every month you see a new architecture coming in. Take, for example, from 2014 to 2017 or so, convolutional networks was what was the definition of deep networks. It was all around pattern recognition, computer vision, all sorts of networks architecture around convolution. And then 2017, the rise of language processing, new type of architectures came in that are called transformers, BERT. They came out for Google first, and OpenAI, and then thousands of academic papers today around those new architectures. So the problem is now if you have a silicon that's very, very specialized for a certain architecture, and then technology is moving very, very fast, software is moving much faster than silicon, you can be in a problem. So you really need to find a point in this spectrum in which you're not too much specialized and you're not too much general purpose. It's not so difficult to program, but on the other hand, it's not very, very easy to program. So finding the right spot on this spectrum is kind of the holy grail. Right.
So you're not Sisyphus pushing the boulder on an architecture that's too narrow, but at the same time, you don't want to lose the efficiencies of the general processing.
Exactly. So for example, at Mobileye, Mobileye is specializing also in building chips. And those silicon, the system on chip, has multiple different architectures. Some of them are very, very specialized to neural networks. Others are less specialized. So kind of to find a better position in this spectrum of ease of programmability and compute density such that you can move with the tide rather than being locked into a very, very specific architecture.
Mm-hmm. And I'm curious too. So what do you view as nothing is ever complete, right? No journey is ever complete. But what would you view as a success point or a major sort of end game for OrCam in general? What are you looking to do?
Well, the end game for OrCam, we call this AI as a companion. So if you look at our smartphone, this smartphone is a supercomputer. But the problem is that it's in our pocket, so it doesn't see and doesn't hear, right? So if you have a device that sees and hears and has the computing capability of a strong machine, then if this device is aware of all what we're doing, shares all the experience, the visual experiences and the audible experiences we have throughout the day, and has intelligence, it can create huge value. And the challenge here is to gradually define what that value is. So what OrCam set out to do is kind of to take society and peel it into layers, where each layer is where we can define very, very precise value to that layer and then move forward. So we started with the blind and visually impaired because the value there is evident. It's very, very clear. You don't see, the device can see, and will tell you what it sees. So this is a great help. And then we move to the hearing impaired, the cocktail party problem, create a much bigger, much stronger experience in terms of hearing help than with the normal hearing aids. But then you can go much further than that. Since you understand that you're aware of the people that you meet, the discussions that you have with the people. Say we're talking and I mention, okay, let's schedule lunch next week. So the AI can do this automatically without even letting me know. So next week It can manage my calendar and put a meeting between you and me, and also communicate with your calendar, with your AI, and do this seamlessly because it was observing our discussion. It knew who you are because of face recognition. It has natural language understanding, so it knows what we are talking about and understands our intentions. So the challenge here is to define this value, and it's difficult to define a value proposition that is good for everyone. This is why we're doing this in stages. But we believe that as the AI progresses, as the compute density increases, as power consumption decreases, so that we can have such a device working for a full day, we can gradually define the value proposition going forward until we enable a value which is good for everyone, not only for people with disabilities, but for everyone. And this is really the end game for OrCam, wearable AI.
Yeah, that makes sense. And the one kind of example that we haven't talked about yet is OrCam Read, right? So the Read app, the Read device is not necessarily for people who are visually impaired, but it mentions that it can aid people who have reading issues like dyslexia, for instance. I'm kind of curious, like why that? It seems like it fits into this layering, that you were talking about building out use cases in sort of tranches. But I'm kind of curious why that detour from that, from sort of the visual and acoustic paths of the other devices.
No, well, the OrCam Read is not a detour. It's really a natural extension of the eye. So the eye, it's like this. It's on eyeglasses. So, if you are blind or visually impaired, putting something on eyeglasses is kind of natural. But if you are dyslexic or you have age-related difficulties in reading, right? It's not necessarily that you want to have eyeglasses. You want to have maybe something that you can handheld, point it, press a button. It will take a picture of text, and then you can also communicate through auditory. You can say, "Read me the headline," just like you did with the MyEye, or read me the entire text, or find the word Facebook and read me the text around Facebook, or start from desserts in a menu. Whatever we do with the MyEye, you can do with this device that you handheld, and then you open it up to new parts of society. Not necessarily people who are visually impaired, but people who have difficulty in processing reading because of dyslexia, because of age-related exhaustion. There are all sorts of syndromes that over time people find it difficult to read text and would like help in reading text. And this simply opens up the market. What we found out is that even people who are blind and visually impaired sometimes prefer a handheld device than a device that you can click on to eyeglasses, which is something that we did not anticipate. So the OrCam Read is also, sometimes shipped to blind and visually impaired.
Got it. And it seems like there is applications there. Obviously, it's English language speaking is like the first target, but it seems like there's awesome opportunities there for translation as well, right? If it recognizes it in one language and can translate it to another.
Yeah, but today machine translation running on the cloud is so powerful. It would be much easier to read, to kind of decipher the text, send it to the cloud, translate it, and then send it back. So it doesn't seem to be a high priority to put all this huge, technology for doing machine translation on a very, very small device. In that case, simply send, because there's no privacy issue here. Send the text to the cloud, translate it, and then send it back.
Makes sense.
Would be a much better route.
Excellent. Well, thank you so much. I really appreciate you taking this time to talk us through OrCam's offerings. I think that this vision for sort of specialized AI in these instances makes a lot of sense.
Thank you, Matthew. Have a good day.
Thank you. Back to you, Will.